time we'll do question 1B of MAT 2007. You see this function here? We're going to find its maximum value. Obviously, we're going to ignore this bit for a while and simplify it to 3 sine squared. What's your favorite letter? I'll go for U. Minus 7 squared. Because we don't care about this bit in the middle, we had to assign U. Let U equals to pi over 2 or pi. For the case where U equals to pi over 2, sine squared U equals to 1. So it's 3 minus 7 squared. This function will return 16. But is that the biggest value? No. When you try pi, sine squared U equals to 0, and obviously this bit will cancel out. Meaning 7 squared equals to 49. So this has a very interesting thing about sine squared functions. Their behavior is especially unpredictable. But if this was an ordinary sine, well, let me just give you a sneak peek. This was just an ordinary sine. You could try U equals to 3 pi over 2 and return 100 as the largest value. And I bet you don't know this, but sine, you go look at some graphs, you realize that sine x looks like this. Well, sine squared x, to some of you, might look like a scaled version of sine x. And it is! And do you want me to prove it to you? Yeah, sure. So we use the double angle identity. Cos 2 theta equals to 1 minus 2 sine squared theta. And then we can get sine squared theta equals to cos 2 theta with 1 minus cos 2 theta over 2. That's a very interesting identity, and you will use this when you're doing calculus. Like, you don't know how to integrate this, you don't know how to integrate chain rule, let's just say, and then you use this double angle formula to get this. So I bet you find these formulas really interesting, and you might use them for your further studies. Who knows? Maybe you'll be a university professor one day, or maybe you use these every day, or just like me, or you might discover some interesting relationships between graphs. Thank you. Goodbye.